Hi, this is Steve with DECWARE. This is a short diatribe about how high fidelity has changed since the 60s from someone who remembers it well. First off, for all you young guys out there that have been told your modern audio gear is the best it's ever been, let me remind you that recording and reproduction has never exceeded what it was in that first decade between 1958 and 1968. We would still be in that blissful audio state today, but the transistor ruined it. Sit tight and I'll go through the sequence of events so you can see what I mean. Remember, in that first decade of stereo, all of the microphones were tube microphones. All of the preamps and recording consoles were also tube. Everything was recorded to analog tape, powered by tubes. All playback systems used tube amplifiers and generally large speakers. The overall transparency that came from low-power triodes and large high-efficiency speakers is something that has been all but buried and forgotten. Towards the end of that magical decade, solid-state transistors became the new buzz. They showed up in radios, and then in audio gear. The transistor made it possible to build an amplifier for less than half the cost. With transistors, you only needed one instead of three, expensive transformers. Since there was no output transformer raising the cost and limiting the power output and frequency range, it was game on for designers. This is when you started seeing higher power amplification. You could get 100 watts for the price of 10 watts, and there was no tubes to replace or wear out. What a marketing opportunity, not to mention major improvement in convenience for the consumer. Transistors, many of them anyway, are like pentodes in so much as they aren't linear output devices like a triode. A single triode tube, when properly set up, amplifies with relatively linear output and minimal distortion. Many transistor-based circuits exhibit nonlinear behavior, which means something has to be done to make them behave in a linear manner. The nonlinear response of transistors can introduce distortion that degrades music quality. So engineers use negative feedback to return a portion of the amplifier's output to the input, out of phase with the input signal. This reduces gain and distortion and improves linearity. While this is a great thing on paper, in our listening tests it can smear the timing in the music enough to flatten dimensional cues in the sound stage and the overall openness of the sound. Since solid-state amplifiers eliminated the need for output transformers, a new challenge emerged, managing the back electromotive force, EMF, generated by the loudspeaker voice coil, which can affect amplifier performance and stability. The back EMF is the voltage generated by the loudspeaker voice coil as it moves within its magnetic gap. In tube amplifiers, the output transformer provides some isolation, reducing the impact of this back EMF on the amplifier. In solid-state amplifiers, which typically lack output transformers, this voltage can feed directly back into the amplifier's output stage, potentially affecting frequency response, stability, and sound quality if not properly managed. The issue doesn't show up during amplifier construction or bench testing because the engineers use a resistive dummy load instead of a speaker for testing. So consequently, the amplifiers always measure great. However, with the difficult load of a loudspeaker and the back EMF, these same amplifiers don't actually sound as great as they measure. Historically, one effective way to mitigate the effects of back electromotive force in solid-state amplifiers has been to increase negative feedback. This reduces the amplifier's output impedance, enhancing its ability to control the loudspeaker voice coil motion and stabilize the system. This process, known as damping, minimizes unwanted speaker resonances and is often promoted as a desirable feature for improved sound quality. Besides the smearing that I often hear, a downside of negative feedback is that it reduces the overall gain of an amplifier, requiring more stages, which means more parts and increased circuit complexity. But complexity is no obstacle when parts are cheap, And since money is more important than sound quality, the market blasted forward and power became inexpensive. And now that power was cheap, the speaker industry began to find ways to reduce the size of speakers to increase sales. To shrink a speaker and maintain low-frequency response, you have to figure out how to move the same amount of air as larger speakers, and do it in boxes that are a fraction of the size. You do this by taking a tight, well-controlled speaker driver and making it loose and floppy. This lowers the Q to work in a smaller box, but at a huge cost. The cone has to be made heavier to lower the resonance, and the voice coil is often designed to be longer than the magnetic gap to maintain linearity during larger excursions. At this point in history, how large the excursions will be are now partially dependent on the amplifier used, so the speaker itself, unlike its old-school counterparts, accepts no responsibility for flatulent bass. So now we have smaller, more manageable sized speaker boxes using woofers. Prior to this, the popular way to get low frequency response was to use very large cabinets, so there is your main trade-off. But now that we have these long excursion, sluggish woofers that can't play mid-range or high frequencies, so we came up with three-way loudspeakers where there is a mid-range and tweeter are added to the woofer. Of course, this requires a complicated crossover, which can also rob power and provide an opportunity for diminished sound quality due to using inexpensive crossover components or inexpensive engineering. The crossover in combination with the woofer approach often drop the efficiency of early speaker designs by 10 to 15 dB or more. That means that speakers now needed up to 10 times more power to reach to the same volume level. But keep in mind, all this time it is called progress. Kind of seems like a vicious circle, doesn't it? No worries. As complaints came in about sloppy bass response, the amplifier industry applied their new universal problem-solving tool, negative feedback. As more negative feedback became popular, more gain was lost, which required additional stages to deal with the lost gain. More complexity, less transparency. And this is continued until the present day and shows no signs of self-discovery or hopes of getting any better. Thankfully, companies like DECWARE and others keep the musical truth alive by building old school, which means that the industry now has two different kinds of amplifiers and two different kinds of speakers floating around, and precious few who understand the difference, or that there is a difference. When components from these two camps are mixed, poor results can be expected. For example, in the 60s camp, we have single-ended triode amplifiers, seldom exceeding 10 watts, and stiff speakers that required large enclosures. The low-power amps had no negative feedback, and the stiff drivers required no help to control the bass. In today's camp, we have high-power amps with tons of feedback that offer high damping control over grossly inefficient speakers with floppy woofers. If you put a modern amplifier on one of these 60s style high-efficiency drivers, two things are going to happen. One, the amplifier will overdamp the driver and completely kill the bass. There won't be any bass. Two, the 10 dB of additional efficiency means you will hear 10 dB more detail from your amplifier. This includes grain, dryness, flatness, noise, hum, or anything else you couldn't hear before because your speakers were too inefficient. If you put a vintage triode amplifier on a modern speaker, there will be too much bass and not enough power to turn the speaker up to a high playback level. The resulting sound will be softened and filtered. This is why some people get great results mixing in some old school and others get the opposite. A great example of this is the review of a licensed version of our Zen Master series Open Baffles on Hi-Fi Cave and Thomas Stereo's YouTube channels. I recommend you watch it now. I'll put a link in the comments section to it. Thanks for listening and have a great day.